Virtualization. Virtualization is the creation of virtual version of something such as server, desktop, storage device, and operating system or network resources. Virtualization plays a very important role in cloud computing technology. Normally in the cloud computing, users share the data present in the clouds like application etc. But actually with the help of virtualization, users share the infrastructure. The main usage of virtualization technology. The main use is to provide the applications with a standard version of their cloud users. Suppose if the next version of that application is released, then cloud provider has to provide the latest version of their cloud users, and practically it is possible because it is more expensive. To overcome this problem, we basically virtualize technology. By using virtualization, all servers and the software applications which are required by other cloud providers are maintained by the third-party people, and the cloud providers has to the pay on monthly basis or annual basis. Normal computer system. In normal computer system, you have a hardware component, operating system, and application. Now when you come for virtualization, one server for multiple applications. So you have a hardware component, you have a hypervisor, and multiple operating systems with multiple applications. Now what is a hypervisor? A hypervisor is a software program that manages multiple operating systems. The hypervisor manages the system's processor, memory, and other resources to allocate what each operating system requires. It operates on a single computer system. Now before virtualization, the system contains a single OS image per machine, software and hardware tightly coupled. Running multiple applications on same machine often creates conflicts, inflexible and costly infrastructure. After virtualization, hardware independence of operating system and application. Virtual machines can be provisioned to any system. It can manage OS and application as a single unit by encapsulating them into virtual machines. Now there is a diagrammatic representation of hosted architecture where you have the application, guest operating system, virtualization, host operating system with x86 architecture. Now unplanned downtime, server failure. Now when you go for this, simple, cost effective, high availability for all resources. So automatic restart of virtual machine is possible in case of server failure. No need for dedicated standby hardware. None of the cost and complexity of clustering occurs. Then benefits of VMware virtualization. Easier, manageable, file server OS can manage data, fault isolation, efficient use of resources, portability, problem-free testing, reduced costs, ability to separate applications, easier manageability. Types of virtualization. When you come for types of virtualization, you have 4 types of virtualization. Hardware virtualization, operating system virtualization, server virtualization, storage virtualization. Now when you come for hardware virtualization, it is full, where in that you have bare metal and hosted. Then it is partial and para. Then when you come for network, it is internal network virtualization, external network virtualization. Then when it is for storage, it is block virtualization, file virtualization. When it is memory, it is application level integration, and next is OS level integration. Next it is software. It is OS level, application and server. Then it is data, which is in the database. Desktop, virtual desktop infrastructure, hosted virtual desktop. Now hardware virtualization. When the virtual machine software or virtual machine manager is directly installed on a hardware system, it is known as hardware virtualization. The main job of hypervisor is to control and monitor the processes, memory, and other hardware resources. After virtualization of hardware system, we can install different operating systems on it and run different applications on those OS. Usage of hardware virtualization. Hardware virtualization is mainly done for server platforms because controlling virtual machines is much easier than controlling a physical server. Types of hardware virtualization. When you go for this hardware virtualization types, you have full, para, partial. Full, in it, the complete simulation of actual hardware takes place to allow software to run an unmodified guest OS. Para virtualization. In this type of virtualization, software unmodified runs in modified OS as a separate system. So software unmodified runs in the modified OS. Partial virtualization. In this type of hardware virtualization, the software may need modification to run. Network virtualization. You have internal network virtualization, external network virtualization. Internal. It refers to the management and monitoring of a computer network as a single managerial entity from a single software-based administrator's console. It is intended to allow network optimization of data transfer rates, scalability, reliability, flexibility, and security. It also automates many network administrative tasks. Network virtualization is specifically useful for networks experiencing a huge, rapid, and unpredictable increase of usage. Then external network virtualization. Combine many networks or parts of networks into a virtual unit. External network virtualization involves actual physical device that caters to your network. This type of virtualization has been around for some time now. A typical example of this would be Cisco networking switch that provides virtual LAN capabilities through its internal Cisco IOS software. Storage virtualization. In this type of virtualization, multiple network storage resources are present as a single storage device for easier and more efficient management of these resources. It provides various advantages as follows. Improved storage management in a heterogeneous IT environment, easy updates, better availability, reduced downtime, better storage utilization, automated management. There are two types of storage virtualization: block virtualization, file virtualization. Block virtualization. It works before the file system exists. It replaces controllers and takes over at the disk level. File virtualization. The server that uses the storage must have software installed on it in order to enable file level usage. Memory virtualization. It introduces a way to decouple memory from the server to provide a shared, distributed, or networked function. It enhances performance by providing greater memory capacity without any addition to the main memory. That is why a portion of the disk drive serves as an extension of the main memory. Application level integration. Applications running on connected computers directly connects to the memory pool through an API or file system. You have a diagrammatic representation where you have a virtualized memory pool, application, contributors. Memory virtualization, you have operating system level integration. The operating system first connects to the memory pool and make that pool memory available to all applications. Software virtualization. It provides the ability to the main computer to run and create one or more virtual environments. It is used to enable a complete computer system in order to allow a guest OS to run. For instance, letting Linux to run as a guest that is natively running on Microsoft Windows OS, or vice versa, Windows as a guest on Linux. Now, types of software virtualization: operating system, application, service. Data virtualization. Without any technical details, you can easily manipulate data and know how it is formatted or where it is physically located. It decreases the data errors and workload. Now, when you come for data virtualization, you have a diagrammatic representation where the application data, where the application can make use of any data that is available and make the user access that particular data, which makes the user feel that all the data are present in their environment. Desktop virtualization. It provides the work convenience and security. As one can access remotely, you are able to work from any location and on any PC. It provides a lot of flexibility for employees to work from home or on the go. It also protects confidential data from being lost or stolen by keeping it safe on central servers. Key challenges in managing information. In order to frame an effective information management policy, businesses need to consider the following key challenges. First one is exploding digital universe. The rate of information growth is increasing rapidly. Duplication of data to ensure high availability and repurposing has also contributed to the multifold increase of information growth. Next is increasing dependency on information. The strategic use of information plays an important role in determining the success of a business and provides competitive advantages in the marketplace. Next, changing value of information. Information that is valuable today may become less important tomorrow. So the value of information often changes over time. Next, data center environment, which is application. An application is a computer program that provides the logic for computer operations. The application sends requests to the underlying operating system to perform the read-write operation on the storage devices. Applications can be layered on the database, which in turn uses the operating system services to perform read-write operations on the storage devices. Applications deployed in the data center environment are commonly categorized as business applications, infrastructure management applications, data protection applications, and security applications. Some examples of these applications are email, enterprise resource planning, decision support system, resource management, backup, authentication, and antivirus applications, and so on. Application virtualization. Application virtualization breaks the dependency between application and the underlying platform. Application virtualization enables the application and the required operating resources within a virtualized container. This technology provides the ability to deploy applications without making any change to the underlying OS, file system, or registry of the computing platform on which they are deployed. Because virtualized applications run in an isolated environment, the underlying OS and other applications are protected from potential corruptions. There are many scenarios in which conflicts might arise in multiple applications or multiple versions of the same application which are installed on the same computing platform. Application virtualization eliminates this conflict by isolating different versions of an application and the associated operating system resources. The characteristics of input-output generated by the application influence the overall performance of the storage system and the storage solution designs.